Okay, shall we have a look at this one then? So this is question 2, just to make sure we're on the right lines. So I've given you all the tools which you need in order to understand this, so hopefully you found this okay. So we have been given that z is equal to 2 root 2 multiplied by the cosine of pi by 4 plus I sine of the pi by 4. So what is the modulus and the argument of z?
Modulus 2, argument pi by 4.
Excellent. Modulus 2 root 2, argument pi by 4. Okay? Which means that if we want to do this, the cube root of z, we can use de Moivre's theorem to find the base angle. Okay? Because cube root of z is just equal to what? Z to the power of a third, isn't it? Okay, so raising complex numbers to powers, we can use de Moivre's theorem, and that will find us the base angle. Now just be careful, how many solutions are we expecting here? How many roots are we expecting? 3, because we're taking the cube root. Okay, so we're expecting 3 roots. So let's find the base one, and then the other 2 will just be equally spaced apart. Okay, so to find the base angle. In fact, a little sketch may well help here. Sorry, not the base angle, the base root. Let's find the base root first. And a little sketch may well help. So first of all, I am going to draw myself a complex plane. So I'm going to draw myself a complex plane. There we go. There's my real number. There's my imaginary number. Now, where is my base root going to occur? Okay, so it's going to be my modulus, 2 root 2. Good, raise the power of a third. Just make sure you raise the entire thing to the power of a third, or take the cube root of the entire thing. Okay, cosine of... Yeah, good. Yeah, good. I'll write it like that first, though, just so people can see. Plus I sine of 1/3 pi by 4. Okay. So if we tidy that up, what do we get? Okay, 6 root 8, like that. 6th root of 8. Yes, I agree with that now. Yeah, because you're happy that 2 root 2 is root 8, which is 8 to the power of a half. Raise that to the power of this, it would be the 6th root of 8, like so. Is that okay? It's better. Okay, so cos of pi by 12 plus I sine of pi by 12. That's my base root. That's Z1. So if you like, it's quite small and it's quite a thin angle, so quite a low angle. So it's going to be about there. So that's my Z1. Okay. Now I'm expecting 2 more roots. Are you happy? And my 2 more roots will occur at equal spacing from Z1. So in fact, what is the spacing between Z1 and, say, Z2 and Z3? In fact, let me make those a bit shorter. So what's the spacing between Z1, Z2, and Z3? How equally spaced are they apart?
2 pi over.
Excellent, because you've taken 2 pi there, and you split it amongst 3 roots. So spacing between that one and that one is 2 pi by 3. Spacing between that one and that one is 2 pi by 3. And the spacing between that one and that one is also 2 pi by 3. Good. Are you happy that the modulus doesn't change of those 2 roots? Okay. So Z2 will still be the 6th root of 8. But the argument will. Okay. So we take pi by 12. If we go for Z2, we're going to move another 2 pi by 3. Do you see that? Yeah? So it'll be pi by 12 plus 2 pi by 3. Plus I sine of pi by 12 plus another 2 pi by 3. Okay? You can go back and tidy this up. So 6th root of 8, cos of, what would that be? 9 pi by 12? Do you agree with that? And you can simplify that. 3 pi by 4. So that's it's fully simplified. Okay? Plus I sine of another 3 pi by 4. Is that okay? Let's go for Z3 then. So Z3 would be equal to the 6th root of 8. So again, the modulus doesn't change. This one down here, the modulus doesn't change. And then it would just be another 2 pi by 3 further on from this root. Or, if you prefer, 4 pi by 3 from the original root.
Yes.
Or negative 2 pi by 3 backwards if you wanted to work from that perspective as well. Okay, but let's go with another 2 pi by 3 further on from Z2. So cos of 3 pi by 4 plus another 2 pi by 3 plus I sine of 3 pi by 4 plus another 2 pi by 3. And then you can go through and tidy this up. So we have the 6th root of 8 times by the cosine of, what do we get?
17 pi by 12.
Okay, 17 pi by 12 plus I sine of 17 pi by 12. Okay, so those are my 3 roots. You see, it's not actually that tricky. You find the base root first, then you just work out how far apart these roots are, and you just add that many roots on until you need it. So I think a sketch is really, really useful. Okay, so that's my first root, that's my second root, and that down there is my third root.